So I was saying, I used to be the cycling artist, and I literally cycled everywhere on my bike for my painting. So I would usually do 2 or 3 days staying at B&Bs, youth hostels. And about 2007 or 8, I was starting to see geology. Now, I had never studied geology. I didn't know much about it. And I visited the Isle of Wight, the Lulworth Cove in Dorset, and this here is Bempton Cliffs. And what you can see in these cliffs, it's not an illusion from the low resolution image. These are all curved layers in the chalk. So I decided I needed to go back and understand this to improve my artwork. I needed to learn the geology. So I went back to the Open University, and these are some of my paintings from in the interim. So this is Isle of Wight, and you can see there's no lines really. There's a few very low down, but not much showing. And I studied the geology, did some coastal geology, and graduated with my diploma in geosciences, which is essentially the bachelor's degree without year 1 science, because I have 2 other science degrees and didn't want to pay to do year 1 classes again. I didn't really need the introductory maths. And you can see, some lines starting to come in to this. I have most recently finished my MSc in space technology and science, and my focus in that was sedimentary geology on Mars. So just for a bit of context, I'm a total geek. There you go. Then 2020 hit, and I was trapped at home. Oh, those paintings are gone. Right, those paintings aren't in the slideshow, apparently. I started doing artworks that combined ink and drawing and paint. And these were all, I'm just making sure they're not later in the show here. Oh, they are later in the show. So these are all postcard size, and these are geological landscapes, but from my memory, because I was in the house, I'd moved the studio home, and the studio was a table, basically. And I thought it'd be really nice to do paintings of primarily Yorkshire cliffs and Norway cliffs from my own visits there. The freedom I got with being able to really play with the ink in particular, which put down really new shapes in the landscape, but also putting the drawing lines in really heavily. As you saw in those previous paintings, there's a few little lines, but that's not what the paintings were about. I was very hesitant to put painting lines in, drawn lines into the painting. But suddenly during lockdown, they came forward. The ink became the shape of the landscapes, and I didn't hesitate putting in lots and lots of lines, and combining both hard edges and soft color, because I always found hard edges a little bit tricky. And as I said, the India ink in particular gave me a really new mark making tool and made different kinds of edges, and it really lent itself to geological structures. So you can kind of see in this last one, it's that craggly edges like mountains. So coming out of this, I really wanted to embrace the geology and not be afraid of it anymore, and put it into bigger work, better work. And I'd started doing a few canvases, but this is where I came up with that deep time idea. And I will flip back here because this is what I decided to draw. This is Selwick's Bay. So this is the place the deep time drawing is based on. These are all Jurassic chalk cliffs. And on the right-hand side of the bay, you can see there's a rock stack. Now, the left-hand side on the very far end of the cliff used to be a second rock stack, and these rock stacks were Adam and Eve. So Eve has completely eroded away. And I liked this idea that Adam is a remnant of the Anthropocene, really. Eve is in photos from 1880. So the eave stack has only crumbled recently, really, the last 100 years, perhaps. This is a sort of closer image of Adam, so you can see where it sits in the bay. This is very low tide, obviously, so the water level does come up to where you sort of see the sandy brown color meeting the darker algae on the cliffs. That's a sort of median high tide you would get. So sometimes Adam's in the water. And we've seen this because I put them in the wrong order. So the first thing I did, being the geek I am, is I went and found all the papers I have from my trips to Selwick's Bay. I've been several times with different geology groups. And the first chart I decided to use was this one. This is a stratigraphy. The sort of rainbowy color in the middle are the layers I was working with. So if you can see that, it's sort of Ferriby, Welton, Burnham, Flamborough. Ferriby is gray and red chalk, which isn't exposed at Selwick's Bay. So that's not in the drawing. So really those green chalk stratigraphies are the ones I was drawing. This is based on time. So this chart shows for the stages of time, so on the very left side are your millions of years markers and how long sediment was laid down in those periods of millions of years. The other type of chart, and this has lots of my own notes on this, so reading through some of my material, I sort of jotted in where there should be faults, where there was uplift, and things like that in terms of the time. The next chart I looked at was what's called a section. Now, the difference here is, well, this one is time units. This one is actual thickness of sediment units. So for example, the Welton chalk, the Flamborough chalk formation is much, much, much more sediment that was laid down over equivalent amounts of time. It's a very, very thick. In fact, so much so that you can see on this chart, it goes from left to right as if the columns go on top of each other. So you've got the Ferriby chalk, the Welton chalk on top. You move down to the next column, Welton chalk into Burnham chalk on top, down to the next column. The Flamborough formation is a whole other page on its own because there's so much sediment. So one of my challenges was taking this information and pulling the idea of the time and the amount of rock sediment and the changes into about an A4 drawing and combining all these things in a way that both is artistic and makes sense. Now, an example of the kind of thing I was looking at for some inspiration is this is from a geology, not geology book, a magazine, the Yorkshire Geological Society. So the idea here, if you look at this little sequence of drawings, is that they drew the first layers, then it got eroded away, then they drew the next layers that got put in, then all of that tilted slightly, a few more layers went in, and then it tilted again. And you can see this in the rock on the top. The trick with those little pictures at the bottom, of course, is that you get 5 pictures to see it. And I wanted all 5 of those pictures to be in one picture, which is how I got the idea of scanning each stage of the drawing and changing it, cutting it, tearing it, and then doing the next layer so that it would be recorded in stages, but there was still only one final image. These are the chalk cliffs I was working from, so just some real quick examples of things I was trying to do. These are conjugate fractures, which happen from stresses in the rock, very high pressures. And this, something that appears in the rocks a lot, is flint bands appear in the limestone. And what happens is the chemistry of the water has changed somewhat. And instead of limestone being formed, flint is formed, a different kind of rock from the same constituents. Now, as you can see in this picture, there are at least 10 major layers of flint in this one height of cliff. So for me to get everything in in the time span I'm looking at, I also had to edit as an artist. I also had to decide what was important to represent, what could be left out without it being completely ignored. So for example, sometimes I just put a few lines in for flint bands. It didn't have to necessarily be 10 or 12. It could be 2 or 3 to represent a period of a lot of flint being laid down. So then I did drafts. So this is still trying to work on how do I get all this time to fit in a drawing. So this is on almost sort of post-it note size images, and you can see I'm just trying to get things in, see how it'll work. A second draft I started cutting as I went and erasing. So I was drawing and gluing bits in, and then drawing and going, oh wait, you know, actually cut it out and tilt it, and ideas like that. And the numbers on the side are parts of those stratigraphy logs that I showed, the columns. Then I did a draft where I hadn't until this point really torn paper. So I got to the point where I thought I'll try collage, you know, how maybe if I overlay things, it was quite a nice way to alter the layers. All of this made me very aware of this is a little demo of me working that'll play. I hope it'll play. So I became very aware that the geology is really physical, strong, these strong, amazing forces, and I needed that to show in the drawing process. So this little demo here has an example of how I decided, oh no, guys, this is telling me our Zoom is going to end in 10 minutes. So we may have to log on. I did not think it would do that. I'll finish this video and then we will have a break and work out how to do this. So anyway, this is me drawing, tearing the paper, overlaying paper for that sort of physical sense of erosion and compression. I was folding the paper and things like that, these massive shifts. Because I wanted to somehow capture how much the rock moves, how much the rock changes, these massive cliffs that we don't think of as being moving. We see them as very static, the landscape, and actually the landscape over, this is 100 million years in these cliffs we can see. And that has not been static. That rock has bent and folded, crushed, cracked, and it was how to show that with my drawing. So here in this bit, you can see I tried with the folding because it's called folding when rock folds. So I thought, right, we will just fold it. And this gives you an idea. This was just a study, but it gives you an idea of the processes I was trying to use. I am just going to pause this for a brief moment. Right, we're ready, we're back. I fixed it, it won't kick us out now. Yes. So yes, you can see what I'm doing here, and you can see the variety of materials I'm using. So I tried marker, I tried black, there's no China ink in here, but I tried the black watercolor pencil inks, the Derwent Graphitone, which goes very black. And then for the very last part, I wanted to represent that idea of erosion. So what happens is the sea usually finds a little weak point in the cliff, and you'll see this as caves often at the sea level. And once it finds that little bit where it gets in, it'll erode slowly, slowly, slowly. And that's how we get sea stouts. There are preferential areas that the sea sort of gets into, and then that's it. That area keeps being eroded away. So this is me going. Right. Now we need this to go to the next slide. Here we go. So my next step was to make my own little chart of the geology, the time, the layers, the events in a sequence I knew I could draw. So this is 3 pages, but this is edited down, believe it or not. I left things out. The dotted lines at the side made me decide at what point I'd take a photo of it. So I'd draw for a bit, and then at the dotted line, I'd call that a time section and scan the image and then carry on. And this is my last draft. Now, I love this one. I just found the mark making really interesting, and I didn't even try to do it on 1 piece. I did it on 4 pieces. I took each page of my own stratigraphy graph and did a section. So I really enjoyed this. And you can see on the right, I've got my own little notes of what things are as I drew them. This one has folds and conjugate fractures. Black lines were marls. So you can see my idea of editing here, where I put quite a few in a row. The next section, I played with white paint a lot in this one. So you can see there's some Chinese mulberry paper painted down. So you're getting a strange rough texture where the paint is almost breaking up the paper. And then I drew on top of that. And I also used acrylic pens for this. It was quite fun. This was the point at which I decided flint would be a gold band. It didn't work well in this one. There's a sort of strange band across the middle that is meant to be mono printed gold paint, but it didn't pull up properly off the glass. The third section, though, I used a gold acrylic pen. So it's acrylic paint pen that gave me these gold lines much more clearly. I really liked how the conjugate fractures worked in this, how it broke up the image. You can even see my note to myself at the very top right, need a fault. There was supposed to be a fault in there somewhere, and I forgot it. And this is the top. So in the top, what happens is limestone, there was a big uplift in a period after all the chalk had been laid down, a much more recent period. There was a big uplift, so everything got tilted upwards about 10 degrees from a fault in the North Sea. And then it was eroded, and then the vertical lines on top are glacial sediment, which is the most current. So it's from the last ice age. We have glacial till, which is sometimes called boulder clay, on top. So that is the physicality of making the work and trying to get in the time. The other thing you'll have seen in the columns and things is different patterns for different kinds of rocks. In geology papers, there tend to be certain patterns used for, say, limestone, sandstone, mudstone, so that there's a consistent key that geologists can look at with any graph or image and understand what the rock types are. Now, as I said, I was trying to take something quite real and a scientific, but make it an art image. I wanted it to be, enjoyable to look at. So there's some textures that I don't like. So limestone tends to be like a brick pattern. I'm not going to draw a brick pattern. That's horrible. So what I had to do was I did some studies that are just plain flat images on paper to look at the kinds of rock I would have and come up with my own key. So this, for example, is my idea of I was playing with this idea of the conjugate fractures so that I wouldn't just get X's. I didn't just want straight drawn X's in my drawing. I did this before I came up with the idea of cutting instead. So I really liked the idea of cutting after I couldn't quite get a drawing to do precisely what I wanted it to do. This is the idea of flint within 2 bands of limestone above and below, and this dark, different rock in the middle. And I thought I'd play with the vertical lines for that. But as you saw, I ended up using just dark, thin lines, because there's at no point in an A4-ish drawing are these thick layers. They're all thin linear layers. This was to experiment with the idea of movement. Since I'm doing a drawing based on change and time, all of these sediments that I'm drawing, limestone and such, they settle underwater. This is all underwater. The sea was at some point much higher when these were laid down. This whole part of Britain was a delta into marine waters. So I thought it might be nice to have, instead of regular lines, have this idea of the rock sediment settling down really slowly over years and years and years. And this one is called fining upwards. And this relates again to how I was saying the sea level changes. So you have limestone at the bottom. Mudstones and siltstones form in deeper water. So you have limestone, and then the sea level must have changed if you have a bit of mudstone. And this is essentially showing that the sea level was deepening. If there's a shift in sediment, it means a shift in environment, a change. So in what's happened in reality here is we have coarsening upwards, which means we have mudstones that then have limestones on top because the sea level was dropping. And limestone is still underwater, but it's shallower water. And this was me playing with how to do folds and uplifts and faults and curvy rocks. The last study is a bunch of erased things on the left side, because of course the most recent event is the erosion. It's the Eve column being gone, the water taking it away. It is the glacial till wearing away into the sea as it goes, and the erosion of the entire cliff face. So for the geologists out there, what I ended up doing was having a key of rock types that is internally correct. So I haven't changed the symbols I've used for rock types within my final drawing, at least. And I'm hoping the sciencey people are okay with that internal consistency. So starting at the bottom, limestones are these kind of swaley, hummocky lines through the final drawing. That is purely because that is what I like to draw. And that is the majority of the drawing. So I decided to choose a pattern I really like. The problem to geologists is that there is actually hummocky and swaley rock. So I'm breaking the rules and using hummocky, swaley patterns for something completely different. Limestone that has nodular flints. So these aren't the gold bands I've done. These are limestones that have the flint really throughout. It's so common, it's called limestone with nodular flints. And these I've put in as straight lined limestones instead of the hummocky lines. The other type of limestone is one with tabular flints. So nodular flints are literally, you know, nodes, round or oblong bits of rock throughout. Tabular flints tend to form in a layer, a connected layer. And after playing with a lot of patterns, I just decided to make it blue. I just thought I'll just use watercolor and put watercolor in the drawing and make it blue. Marls are just dark lines. So the three examples here are India ink, monoprinting, and actually the third one's India ink as well. I thought that was a pen for a second. And marls are a very important marker because they're a big environmental change. They are not underwater. Something has very much shifted in the environment when there's a marl present. Oops, wrong way. And then lastly on top is the flint lines, when it's a good, important flint layer that geologists recognize. I did those in gold because I like gold. This is the entire sequence of stages in the end. And this is the final drawing in the end. So you can see I have collaged on layers of Chinese mulberry paper. There is some monoprinting going on. I've cut things and shifted them. and torn paper. It was really, really good fun, actually. And while the print set does record the process, I think what I really did enjoy was knowing that once I changed a layer, that layer was done, it was gone. There are pieces gone from this, entire sections that were torn off as I went. And as an artist, that was a really interesting experiment because I've always done very still images. This in the end is the bookmark I did to go with them. So it connects the stack I've drawn with those time eras in the geology papers. And that was it. Now, what I was going to do was stop the sharing. If you would like, I can go through the stages one by one with a screen share, if you'd like me to just kind of flip through that so you can see it. It's down to everyone's time commitments, really.
Yes, please.
Excellent. I will do that then.
Ditto.
Yes.
Let me just find. Flip over to the other side. So this is the bit of slideshows I was saying earlier. I'd forgotten to get ready for today. Right, so I will share with you. This is the actual drawing process. So each stage of this has ended up as a print in, it's a sort of postcard size print set. So first I put down some dark India ink, almost as a base. It's meant to sort of be the Ferriby chalk, but I thought it just gives it a nice anchor. Drew in some of the Weldon chalk, a nice flint band in the middle, and you can see a shift from regular limestone below the flint band to nodular flint limestone above that, and then some marl, so something changed. Over time, it all compressed, and then some new limestone started to be formed. More limestone, some marl bands on top as a marker again. Marlstone makes a really good marker for when to change the image because it is an environmental change. Again, compression came, so I used some tearing of the paper here to show compression. Those marl bands and a flint band on top, and some new limestone going down. So these are millions of years happening here. That compressed, topped with a marl, and we have some new stuff. We're getting into the I'm forgetting the name of it. I'm going to check my little cheat sheet. My little cheat sheet isn't here. Where is it? I want to say Burniston. It's not. Burniston is local. It's the Burnham chalk. I'm getting confused between a village and the name of the chalk. And then we have some faulting from the North Sea. So these are those fractures you saw in the cliffs that happened. Then some flint and some marl bands as a big, significant area of layers there. And now we start the proper Burnham chalk. And so, of course, you can see the big change is that the Burnham chalk has tabular flints. It's blue. Blue. Some compression, some more tabular flints. What you have here is erosion cut the limestone, and then new limestone came on top, but you can see I've left a small line of white. That is a very significant layer called the oyster bed, which geologically is very specific in date. So it's quite a key layer in the geology. So I have left that as a white line where the oyster bed is. And there are loads of oyster fossils. It's very cool. They're massive and they're just there in the sides of the cliffs. Then we have a lot of marls again, a big shift, lots of marls, a dipping event, a fault and a dip, shifting the top of the Burnham chalk. More limestone, and then a big erosion event. Erosion, missing layers in geology is missing time. It usually means erosion. A lot has been taken away, although there are sometimes layers that geologists think should be there, and we don't know why sediment wasn't laid down. So it may just be something really different in the environment, and we don't know why that time is missing. But boundaries are time, essentially. A nice flint, marls, and now we're starting into the Flamborough chalk. So it's white again, so nice regular limestone with a nice marl, some erosion, and then lots and lots. So my idea of depicting the Flamborough chalk as being so much thicker was to not actually worry about the physical thickness of my drawing, but simply to draw lots and then erode it and slump it. When it was still soft enough to slump, it sort of dipped, which is quite different from a fault, which means when you have a fracture like a fault, it means the rock was harder, so it couldn't bend. There are folds in our chalk as well, not at this bay, but at a nearby bay, which shows that the chalk had to have been ductile enough to actually almost flow. There's like Z folds in it. Then I have that uplift event I told you about that was more recent, happened millions of years after the Flamborough chalk was actually laid down. There was the uplift event that shifted all those layers. And finally, the Ice Age and glacial till. So glacial till is movement mostly from north and inland a bit out to the sea, or actually from Norway and over. And it is sediment that glaciers have left behind as they moved back and forth. And lastly, erosion of those layers, because we only have a top layer that's so thick. And that's the final drawing. So that is it. And the actual final drawing is on its way to Spain for the lovely person who backed it to actually have it. And he's going to mount it and frame it there, thankfully, because it is such a weird size. It went a little bit over A4, so it has to be custom mounted. So I will stop that and see if there are any questions and stuff. I will stop recording now so that if you want to ask questions, you don't have to be on the recording.